So now we're going to do a larger function with the rational root theorem. Let me type it up here real quick. Text. Rational root theorem. And we're going to specifically talk about multiplicity today. Okay? I want to kind of talk about multiplicity. And when we're talking about multiplicity, is sometimes you have the root twice. And you have to check for that. And so let's work this problem here. So let's draw a problem. Let's come up with, let's do this one here. X to the 4th plus 4x cubed minus 5x squared minus 36x minus 36x minus 36. Okay? So, and I want you to determine and work this with me. I mean, work it on your own scratch sheet of paper as you work through it. So let's start off with our P's and our Q's. So let's go to our P's first. So when we do our P's, we are looking at this 36 here. This is what we're looking at. And if you did your P's, as you look at that, you say, okay, what two numbers can multiply and get 36? Well, I know 1 times 36. I know 2 times 18 will do it. 3 times 12 will do it. 4 times 9 will do it. 6 times 6 will do it. So let's write it in right format. Plus or minus 1, 2, 3, 4, 6, 9, 12, 18, and 36. So that's how we do our P's. 1 times 36 is 36. 2 times 18 is 36. 3 times 12 is 36. 4 times 9 is 36. And 6 times 6 is 36. So then we do our Q's. Let's do our Q's. Our Q's. Well, now we're looking at the leading coefficient, which is right here. That's an invisible 1, so it's plus or minus 1. So now what we want to do is write what is our possible roots. What is our possible roots? This is what the rational root theorem tells us. Our possible roots are P divided by Q. So they are plus or minus 1, 2, 3, 4, 6, 9, 12, 18, and 36. Now, that's just possible roots. So that doesn't mean all those are roots. They're just possible roots. So we have to evaluate that using synthetic substitution, or we know it as synthetic division. We have to evaluate that and go through each of these values and find out which ones work. So let's just start. What's the best place to start with is plus 1. So we go plus 1. And let's see what we get. Plus 1 here. There you go. So our coefficients are 1, 4. Let's see, negative 5, negative 36, and you should be working this on your own beside me as I'm going through it. You should be working it too as practice. Many of you may have already finished it because I'm repeating myself about 3 times, but go ahead and practice it. So let's bring down 1. 1 times 1 is 1. 4 plus 1 is 5. 1 times 5 is 5. Negative 5 plus 5 is 0. 1 times 0 is 0. Negative 36 plus 0 is negative 36. Negative 36. Well, that gives negative 72. Oh, so that doesn't work. Well, let's try minus 1. So let's try minus 1. Or negative 1. Same coefficients. 1, 4, negative 5, negative 36, negative 36. Draw my line. Drop the 1, negative 1, 3, negative 3, negative 8, 8, Let's see, that is negative 28, negative 28. That's positive 28, and that's negative 8. So that didn't work. Well, let's go next to 2. Okay, so let's try 2. Plus 2, plus 2. Drop my 1, my 4, my negative 5, my negative 36, and negative 36. Let's see what happens with the 2. Bring down the 1. 2 times 1 is 2. 4 plus 2 is 6. 2 times 6 is 12. Negative 5 plus 12 is 7. 2 times 7 is 14. 36 minus 14 is what, 22? Is that right? 22, yep. That'd be negative 22. 2 times negative 22 is negative 44. Let's see, that gives me a negative, well, it doesn't really matter, but negative 83, let's say. Negative 89, 4, 6 is 0, negative 8. So that doesn't work. So let's try minus 2, negative 2. Let's try negative 2. And that's why I said some of you I know will just use total math or other opportunities and go straight to the answers. But be careful, because on the test I can tell whether or not you've done these steps. And it's important you learn how to do these steps and get in the habit of doing them. As you go down and do it in a process, drop the 1. Negative 2 times 1 is negative 2. 4 plus a negative 2 is 2. Negative 2 times 2 is negative 4. Negative 5, negative 4 is negative 9. Negative 2 times negative 9 is positive 18. Bring down the negative 18. Negative 2 to negative is positive 36. And there's a 0. Hey, we got a solution. So we can first write down, let's write down what we got so far. So far we know this is a solution. So x plus 2 times, what am I left with? Well, that's 1 represents x cubed plus 2x squared plus 2x squared minus 9x minus 9x. Let's see here, minus 9x minus 18. Okay, well, that's still a cubic, so we can't just come up with that in our mind, so we have to do this process again. So let's continue on. Remember, use this number one more time, so because we have to check for multiplicity. So let's try minus 2 with the new equation now. So we were trying a new equation now. So this is 1, and that looks like a 2, negative 9, negative 18. Draw my line, bring down the 1. Negative 2 times 1 is negative 2. That gives me a 0. That gives me a 0. Negative 9. Negative 9 is positive 18. That gives me 0. So we have another solution. This is the case of multiplicity. It's why you cannot just do the solutions. You have to go through this, because now this becomes x plus 2 times x plus 2. And I am left with x squared minus 9, x squared minus 9, which we know to be x plus 3 and x minus 3. And we can write this in a normal format, which is x plus 2 all squared. So that would be my completely factored form. My factored form, if I was looking for a factored form. If I was looking for solutions, the solutions are x equals negative 2, because there's 2 of those, a negative 3, and a positive 3. And just like x to the 4th, that's why we have 4 solutions, and they are all real solutions. We have no imaginary solutions. They're all real solutions. So that's kind of the process as we work through there. Do you have any questions?